we are going to choose the capacitor for our buck converter, and in this case the selection is very simple because the capacitor will work in a very ideal way, taking into account the operating conditions of our buck converter. In this way, for instance, the power losses of this capacitor are negligible, and well, basically because the parasitic resistors or resistances of that capacitor are very small. So we only have one rule for choosing the capacitor, and that rule is that the rated voltage must be equal or higher than 1.5 the expected voltage across the capacitor. What is the expected voltage across the capacitor? Well, it's simple, it's the output voltage. This is the voltage we have across that capacitor. So in our case, that output voltage is 3.3 volts. So if we multiply this with 1.5, we obtain 5 volts. So we need a capacitor with a rated voltage of 5 volts or more. So as I said, it's very simple. Now we can choose a capacitor, checking in internet. For instance, this is the one that I have chosen. It's from TDK, a very popular manufacturer. I want to highlight the type is multi-layer ceramic. It's a multi-layer ceramic capacitor. I think that this is a good option because they achieve, let's say, very high capacitance in a small size, and they work very well up to high frequency. The individual capacitance is 47 microfarads. Remember, our target is 230 microfarads, so we are going to put 5 capacitors in parallel. In this way, the equivalent capacitance is 235 microfarads. Rated voltage is 10 volts, so it's enough. And here you can see the individual size and the total size when you consider the 5 capacitors in parallel. Well, if we want to include the capacitor in our LTspice circuit, it's very simple because we consider the device as an ideal device. We only put a capacitor. Here we have the equivalent, the capacitance equivalent for the 5 capacitors in parallel. Okay, so with this we finish with the capacitor selection. See you in another video.